Welcome back to another exam prep explainer. Today we are focusing on exactly this, NCP-MCI 7.5-6.9 VM high availability. If you're an infrastructure admin gearing up for your certification, you are in the exact right place. We're going to take a steady-paced, highly detailed look at baseline AOS 7.5, AHV 11.0, and Prism Central 7.5. Specifically, we're doing a comprehensive deep dive into the exact mechanisms you absolutely need to master regarding virtual machine high availability. Look, we're not just going to memorize a list of facts here. We are going to deeply understand the underlying logic of the hypervisor so you can confidently tackle literally any complex scenario the exam throws at you. So get comfortable and let's get started.
Here's our blueprint for today's explainer. We'll start with why VM high availability matters, compare best effort versus guaranteed modes, walk through some concrete host failure scenarios, navigate the most common exam traps, and finally, lock it all in with key facts to memorize.
All right, let's jump right into Section 1, why VM high availability matters, looking specifically at infrastructure survival in AHV.
To set our baseline, let's quickly nail down our core terms. AHV, or the Acropolis hypervisor, is your native Nutanix virtualization solution. And within that ecosystem, we have VMHA, which stands for Virtual Machine High Availability. Simply put, this is the built-in native system designed to protect your critical workloads. In an enterprise environment, the stakes for unplanned host failures are, well, they're incredibly high. A sudden power loss or a catastrophic node failure can mean thousands of dropped transactions or just massive productivity losses. VMHA is the mechanism that ensures your VMs restart automatically on the remaining healthy nodes in your cluster. It's essentially the ultimate safety net for your infrastructure. But, and this is a big but that you'll see tested heavily on the exam, how that safety net deploys depends entirely on how you, the admin, configure it.
Moving on to Section 2, best effort versus guaranteed modes. This is the core contrast of the whole topic.
Let's unpack the vital difference between these two operational modes. By default, AHV operates in best effort mode. Honestly, think of this as crossing your fingers and just hoping for the best. In best effort, the system doesn't reserve any resources for failover. There's absolutely no admission control. If a host dies, Acropolis just looks around the surviving cluster for any available space and tries its hardest to restart the affected VMs. If your cluster is running hot and resources are tight, well, some VMs simply aren't going to power back on. On the complete other side of the spectrum, we have guaranteed mode. When you enable this by explicitly checking the Enable HA Reservation box in Prism, you are turning on strict, ironclad admission control. The system explicitly locks down cluster capacity to guarantee that all protected VMs will successfully restart during a failure. You are taking hope completely out of the equation.
The underlying engine that makes guaranteed modes so bulletproof is a mechanism called segment-based reservation. You definitely need to know this for the exam. Instead of just setting aside a raw, unstructured chunk of memory, the scheduler mathematically divides the cluster into segments. And here is the absolutely crucial detail to remember. Each segment is sized to correspond to the largest VM that it guarantees to restart. Now, why does it do this? To prevent memory fragmentation. Imagine you have a massive SQL Server VM. Without segmenting to the largest VM, your cluster might have enough total memory spread out across the nodes, but not enough contiguous unbroken memory on any single host to actually boot that massive SQL workload. By sizing these segments to the largest VM, Acropolis ensures it always has the unfragmented blocks necessary to power on even your heaviest workload. And Acropolis dynamically recomputes this, usually setting aside 1 to 1.25 times the resource usage of your most loaded host.
Okay, Section 3, concrete host failure scenarios. Let's walk through how this actually applies in the real world.
For our first scenario, imagine your cluster is running in the default best effort mode. Step 1, a host suddenly suffers a catastrophic hardware failure. Step 2, Acropolis immediately detects this heartbeat loss and attempts to restart the orphaned VMs on the surviving hosts. But let's say it's 3 a.m. on the last day of the month. It's month-end reporting time, your pagers are absolutely screaming, and your remaining cluster resources are fully maxed out. Step 3, because there is no admission control enforcing boundaries, there is simply no physical space left. So step 4, the restart fails. Your users experience extended downtime, your inbox fills up with angry emails, and you're going to see a critical Prism alert specifically stating a failure to restart VMs due to insufficient memory or CPU. Not a fun night.
Now, let's look at a completely different outcome under guaranteed mode. Step 1, that exact same host fails at 3 a.m. But this time, in Step 2, Acropolis seamlessly taps into those pre-sized reserved segments we just talked about. How were those segments protected? Because strict admission control was enforced long before the failure ever happened. For example, if a junior admin tried to spin up a massive, unrelated test VM on a random Tuesday afternoon, Prism would have actively blocked them if it meant eating into these reserved guaranteed segments. So, step 3, because those resources were violently protected, all protected VMs restart successfully, no matter how heavily loaded the rest of the cluster is. The reserve space was guaranteed, and hey, you get to go back to sleep.
Let's pivot sharply into Section 4, Common Exam Traps. It is time to navigate the minefield.
Here's a very common, and honestly a very tricky exam trap. The test designers love to evaluate your understanding of what an absolute guarantee actually covers. So the question might ask, if you have guaranteed mode enabled for your cluster, does that strict guarantee extend to a VM that has specialized physical hardware attached? Specifically, an NVIDIA vGPU, or Virtual Graphics Processing Unit.
The crucial point to remember here is that the cluster does not reserve specific resources for vGPUs. Even if the rest of your cluster is locked down tight in guaranteed mode, VMs with vGPUs are always, without exception, restarted on a commercially reasonable, best-effort basis. Think about it. The hypervisor can't magically conjure up a physical GPU out of thin air on a host that doesn't have one. Because of physical hardware constraints, that VM will completely fail to start if the target failover host lacks an identical, compatible vGPU profile. You simply cannot fail over a vGPU-backed VM to a host that only has standard compute resources available.
All right, here's another massive trap that relies entirely on which Prism screen you happen to be looking at. When you enable high availability reservation, a substantial chunk of your cluster's memory is locked away. But how does Prism actually display that reserved memory to you in the UI?
Depending on where you look in the UI, you actually get a completely different answer, which is exactly why the exam tests this. The logic behind the UI difference makes sense once you understand it, though. The Prism Element Home dashboard gives you a holistic, high-level business view. Therefore, it includes both the memory consumed by running VMs and the memory reserved for your HA failover insurance policy. However, if you click over to the Analysis dashboard or the Hardware page to look at hypervisor memory usage, those graphs do not include the HA reserved memory. They're showing you raw current physical metrics, only what is actively being used by the hypervisor and running VMs at that exact literal second. You really need to memorize this distinction between the business view and the raw metric view.
Let's tackle one more complex interaction where the exam will definitely try to trip you up. You need to know how HA interacts with ADS, Acropolis Dynamic Scheduling, specifically when memory overcommit is turned on. If you're using guaranteed mode to reserve segments and you have VMs with memory overcommit enabled, the system has to perform a strict calculation. Let's say a VM has 100 gigabytes of memory configured, but it's currently only using, say, 40 gigabytes. Well, guaranteed mode doesn't care about the 40. It forces the system to reserve exactly 75% of the configured memory, so it locks down 75 gigabytes to ensure that VM can be fully recovered if its usage suddenly spikes. This mathematically reduces the total memory available for usage by other VMs, fundamentally lowering your cluster's maximum theoretical overcommit density. That 75% reservation, that is the literal physical price you pay for guaranteed safety.
Finally, let's wrap up with Section 5. Key facts to memorize. Let's build out your final cheat sheet.
Commit these 4 specific mechanisms to memory. 1. The default out-of-the-box HA state is always best effort, meaning absolutely no admission control. 2. Guaranteed HA achieves its reliability by using segment-based reservation. 3. Those segments are always sized to accommodate your largest VM to prevent contiguous memory fragmentation from ruining your failover. And 4. VMHA does not reserve memory for non-migratable VMs. Think about it. If a VM is physically tied to a specific host via strict affinity rules, it's not allowed to move anyway. Therefore, the cluster is smart enough not to waste precious reserved segment space on it elsewhere.
As you finalize your NCP-MCI exam prep, ask yourself this. Look at your own production clusters tomorrow morning. Are you operating on a strictly engineered, admission-controlled survival plan, or are you just relying on best-effort hope? Because in the world of hyper-converged infrastructure, hope is not a strategy. Master how these segment-based reservations enforce contiguous memory limits, and you will easily master this section of the exam. Keep studying, and we'll see you in the next explainer.